our one returning Paths Up participant from.
You didn't have to tell them that. Now they're going to expect more.
They should expect more. They should expect more from Mr. Daniel Andrew. He's going to talk about applying supervised learning algorithms to predict early stage diabetes. So here we go, Daniel. I'm going to get your slides ready.
Yeah.
And then I'm going to turn it over to you.
Well, good morning, everyone. As Alan mentioned, as I'm the returning, I guess the lead teacher for this group. I am going into my 7th year teaching computer science and coaching basketball at Springwoods High School, which is in Spring Branch ISD. The pictures you see there include a big personal milestone of mine. I got married back in March. So, I'm sharing that with everybody because we're still in the really early stages of it, super happy about it. Hopefully it continues to be that way, forever. And pre-COVID good times with some students there competing at HP Code Wars, and then a picture of my basketball team that won the school's first district title in history. And the school's been open for about 63 years, I believe. So a little bit of background: diabetes runs in my family. Type 2 diabetes makes up for most of the cases, mostly due to lifestyle choices. And pretty harrowing scenario. US adults overall have a 40% chance of developing type 2 diabetes. And if you're Hispanic and Latino American, like my family that you see there before you, we're all Mexican mostly, our chances is even higher, 50%, and most likely to develop it at an earlier age. So early detection of diabetes is really important for a clinically positive outcome. So the description of what I did was I found a data set that involved 520 patients and contained about 17 data points, most of them being categorical, like yes or no answers to questions about symptoms, like whether you had sudden weight loss, partial paralysis, frequent urination, etc. And you can see that the data set is mostly made up of about 61% of people who do have diabetes. So the research question I wanted to look at was, could we use supervised learning to compare some of these symptoms and determine whether or not a person is diabetic? And I used 3 supervised learning algorithm models: logistic regression, which is a linear regression model; random forest, as my colleague explained in good depth; and then also a neural network. I chose these 3 because they were all very different in terms of like the statistical background and how they operate and fit the data. And it turned out that for this particular case, random forest was the best, had the highest accuracy score and lowest misclassifications of patients with diabetes. Some of the highlights that I got from this experience was learning how to do a lot of pre-processing. So having a data set that contained non-numeric values presented challenges because I had to transform those text values into numeric values to be able to do some of the feature scaling techniques, standardization, and ultimately be able to actually fit that data to these models that I mentioned earlier. And then I spent a lot learning about ways to evaluate those models using cross-validation. Some of the highlights for the speaker series: I enjoyed all the presentations and greatly appreciated the instructors and graduate students who spent time with us this summer. My biggest takeaway was that all of the presentations all were directly tied to developing technologies that were low cost and could be easily scaled for communities of underserved populations, which I think just gives me a lot of hope and optimism for the future. Collaboration remote experience was tremendous. We had such a diverse group of people. We have former chefs, military, and we even have, I think, a DJ in the crew. And some of us have been teaching for over 20 years. So all of us coming together in a remote experience, which is very challenging, I'm very proud of what the group did and what we were able to accomplish, and everybody taking on the challenges head on. So I just wanted to give them a shout out. They made the experience wonderful. For my lesson, Amira and Cheryl have already kind of mentioned sort of what we're hoping to do. So I'll talk a little bit more about the tool Google Colab, which is basically a free open source way to run interactive Python and also have text and images and videos sort of embedded within that. And it's a great way to introduce students to machine learning because you don't have to worry about any of the technical aspects of installing Python and all of those libraries that you need to be able to do some of these tasks. For future plans, I hope to leverage my experience and gain knowledge for my students' benefit. I want to continue to study data science and machine learning further. And I have looked at those programs that Derek mentioned as well, because I just find this whole field very fascinating. I want to continue to learn more. Definitely want to get that lesson published on Teach Engineering, and hopefully we win more games this year than we did last year. Last year was not a great season for basketball, so fingers crossed we'll do a little bit better. And lastly, this is my research poster. I talked about most of the things on here. I guess the only thing that I'll focus in on is the research question that I posed was, could we use supervised learning algorithms to predict early stage diabetes? And with the models that I chose for this classification task, I think you can say the answer to that is yes, the predictions were made at a relatively high accuracy rate. The other thing that I learned was the importance of pre-processing, because there's so much that you can do before you try to fit any of the training data into a specific learning model that could greatly improve the outcome. Just some next steps in terms of what I would do to carry this particular experiment further would just be to look at how I would implement feature extraction to reduce data set dimensionality and help maintain that performance level while also making a model that's more scalable, as Derek was mentioning earlier. And I would like to learn a little bit more about hyperparameter tuning and different strategies such as grid search and random search to, again, improve those outcomes. This is my second chance getting to do this, but last year was slightly different. So I really enjoyed focusing on doing classification tasks with supervised learning algorithms. And I just want to give a shout out and thanks to my mentor, Tianyi Zhang, Ellen, of course, and the entire PASSUP team, Rice Office of STEM Engagement, and NSF for Research Opportunity, and all my teammates. Thank you guys for making this a great 5-week experience for me.
Thank you. Thank you very much, Daniel. I think I want to start with that first question, that kind of where you left off. How was your experience this summer different than it was last year?
So I think having gone through a whole year of Zoom, I think I was a little bit more ready for it. So I think just working, it's different when I imagine everybody can kind of relate to this, when you've got a group of people you can collaborate who are right next to you working on stuff, and then you're in one location and there's no distractions except for what you're doing, and I got a little bit more used to it. But I think mainly my role change was the biggest difference, right? So having to try to come back and sort of answer some questions and take on a leadership role and make sure everybody knew what the deliverables were and try to encourage collaborative spirit was different for me, because I'm a singleton at Springwoods High School. I don't have a team. I'm the only computer science teacher. So I think I learned a lot about how to work with people through this experience in a different way, where I was a little bit more having to be a little more responsible for the group as opposed to just my individual part of it.
Good, absolutely. So speaking more of what you implemented last year, they're asking, did the students have fun? Were they fully invested in kind of the things that the lesson you put together last year? Were you able to implement your lesson at all due to the pandemic?
So the lesson we did last year involved using OpenCV, which is a computer vision, and it's a very popular library that has implementations in several programming languages. And the focus was on trying to determine, where the face was in a webcam feed. So because of the nature of this school year, I wasn't able to deploy the lesson that we developed in a normal class setting, but I did do it with my club, computer science club kids. And they loved it. I mean, the fact that they wrote a program that when they ran it, started a live video feed that was then, real time drawing a bounding box around where their face was, and they moved it around. They were 100% totally fascinated with it. Now, this particular lesson that we're talking about is developing with Amira and Cheryl will be a little bit different, because there's no fancy visual that they'll get to see like that. But I think the connection to diabetes and how prevalent it is in the world, and I'm sure given that at least at my school, most of the population is Hispanic, they will have a really strong connection to it. And just in general, I found anytime you can do anything cross-curricular with computer science, where it's not just coding, it's why coding is important to be able to do and how it affects this field, or whether it's healthcare or entertainment or whatever. I think most students just think of coding as making video games. And so I think showing them different ways that computer science affects other areas really opens up the eyes for a lot of my students. So I think I answered that question.
Yeah, no, absolutely. I'll ask you one more question, and then I'll maybe ask one more.
I'm charging you for this one. Just let you know.
I mean, I've asked most people 3.
Okay.
You know, this is on par with what I'm doing. Okay. What was the most surprising thing you learned from your research?
I think how much I don't know and how much I really needed to pay more attention in statistics when I was getting my undergrad in computer engineering. That's why I mentioned the interest in pursuing more knowledge in data science. I think there's like some foundational things that, like, being able to know more about those models, like why a linear regression model or a decision tree model is better for certain types of problems, are a little more challenging for me to explain and require a lot more just investment in trying to learn that. So I think that's the most surprising thing, because as Derek was mentioning, it's pretty easy to do stuff with machine learning and do some basic tasks, but I think to be really like dangerous, you have to start to learn a little bit more about the intricacies and the nuances, and it's an art form, right? Data science is an art form, just like programming is an art form. And I think just a little bit more on my end to understand it better, and I don't mind that at all, because I think being somebody who's always looking to learn new things is the way I stay motivated for my students.
Thank you very much, Daniel. We really appreciate that, and we really appreciate the role that you took on this summer as well to kind of be a coordinator of sorts, and we definitely appreciate that 100%.